So this is 4-5's homework assignment. We're on page 214 in the textbook. And we're looking at inequalities today. And we got 1 through 11, 18 to 20. So number 1. So two hot air balloons are descending, constant rate. They both start at the same time, but at different elevations. Tell you this one starts at 7 and this one starts at 550, shown in the graph. So give 3 values of t, so where the green balloon is higher. So the green balloon is higher for all of these values till it hits the purple and then goes underneath of it. So it says give 3 values. So anything less than 10, basically. So I'm going to say 2 and 4 and 6. But lots of different answers there. Anything less than 10. So using that same line of thinking, write an inequality that describes when the green balloon is higher, and that's when everything is less than 10. So when t is less than 10. Letter C, write an inequality that describes when the purple balloon is higher. So it's higher after 10. So when t is greater than 10. Okay, number 2. In a typical year, a willow tree grows 3.5 feet, and this other types of tree grows 2 feet. So suppose a 6-foot willow tree and a 13-foot catalpa tree were planted at the same time. So which tree is taller 2 years after they were planted? So we're going to kind of make a little chart here. So let's start with the willow. And this one we're just going to put a CH. So for the willow, it starts at 6, and then it's adding 3.5 per year. For part A, they're talking about 2 years. So that's 6 and 7, that's 13. And for the other one, it starts at 13, and it's going to obviously add. And it's growing by 2 feet per year. So that's a total of 17. So for part A, it is the catalpa tree. And let's see, part B. Which tree is taller 10 years after? So we have 6 plus 3.5 times 10. So that's 35 plus 6, that's 41. And this other one is 13 plus 2 times 10. So that's 20 plus 13, so 33. So now the willow tree is taller. Okay, letter C. Write an inequality to describe when the willow tree is taller. So the willow tree is 6 plus 3.5. I'm going to use x for the years. We want to know when is it taller. So when is it greater than 13 plus 2 times x? So that's the inequality. When they say write the inequality, that's all they're looking for right there. And for letter D now, they're going to ask you to solve it. So letter D, now kind of doing what we were doing in this lesson, you've got x on both sides. If you get rid of the smaller one, we avoid negatives, and then we never have to flip. And so that helps us out, avoids mistakes. I've got x on one side, so I'm going to get rid of everything else. Divide by 1.5. So 7 divided by 1.5, 4.6 repeated. And what is this in? Solve the inequality, and this is talking about years. So we're going to say about 4.7 years. And it's not asking you exactly when are they equal to each other, it's asking when is it more. So x is greater than 4.7 years. So you could have left it as x is greater than 7 over 1.5. Now normally we don't leave a decimal inside a fraction. So if you noticed in the answer key, the number they gave you was 14 over 3, which is an equivalent fraction to this one, just without the 1.5 in it. So knowing that I can double 1.5 to make it a whole number 3, you double the top, and you've got that right there. But the important part is that we understand how to solve this. Give us our final answer. X is greater than about 4.7 years. Okay, we're not getting hung up on the exact amount right there. Okay, number 3. So we're going to solve this by adding negative 5m to both sides. Now that's what I would recommend you doing, because out of the m on both sides of this inequality, that's the smaller one. And so when we do that, we end up with positive m, which means we never have to flip anything. Divide by positive, so leave it alone. So m is less than negative 10/3. If you want to flip it around the other way, keep it closed towards the m. Looks like that. So part B now, they want you to start with the same inequality, and now they want you to solve it by adding negative 8m to both sides. So this should still work and should still get us the same answer, but what it's going to do here is going to create a negative 3m. And so when we're going to end up dividing by negative 3, we're going to end up flipping this, but you'll see you still get the same answer. So I divide by negative 3, and when I divide by negative 3, I have to flip. So this now goes the other way, and it's negative 10/3. When one of these is negative, it's a positive divided by a negative, so your answer is negative. So notice, it's the same answer, but I had to know to flip it. So because I didn't get rid of the smaller one, I created a negative coefficient. When I divide by negative, I have to flip. So as long as you follow all your rules, you still get the same answer. So you don't have to do one over the other. This isn't incorrect, but there's a chance you forget to flip. A lot of you forget to flip when you're dividing by a negative. So don't even make that happen. Always get rid of the smaller one. So C, should you get the same answers for part A and B? Yes. Okay, we're still going to get the same answer. And then D, describe how the steps are different. We just talked about it, so you can put that in writing. But when you get rid of the smaller of the two, it keeps your coefficient positive. When you get rid of the larger of the two, it creates a negative coefficient, which is extra important when we're dealing with an inequality because we have to remember to flip. But in the end, you do still get the same answer. All right, so just now rocking and rolling with solving some of these 4 and 5. I asked you to do the checks. The rest we don't have to. So A on both sides. Let's get rid of the smaller one, make our lives easy. So I have 4a plus 4 minus 4 divide greater than or equal to 6. So remember, for an inequality, there are 2 checks. Check number 1, plug it in with an equal sign. So 42 plus 4, I'm going to get 46 on this side. 18 plus 28, I'm going to get 46 on this side. So that check works. That tells me that 6 is the right number for here, but is this greater than facing the right direction? We got to test that out. So we go back to the original. Plug in a number that's in this solution set. So I need a number that's greater than 6. So I'm going to pick 10, something nice and easy to work with. So 7 times 10 plus 4 greater than or equal to 3 times 10 plus 28. So 70 plus 4, that's 74. 30 plus 28, that's 58. 74 is greater than 58. That's true. And so I know that this answer, the 6 is correct, the greater than is correct. Good to go. All right, number 5, we'll also do a check, and that'll be the last one. Okay, x on both sides. I'm going to get rid of the smaller one. So I have negative 53 plus 5x, add 8. Should be negative 45, divide by 5. And x is still here. open towards the x, so that's greater than or equal to 9. Okay, 2 checks. Check number 1, back to the original with an equal sign. Plug in -9. So I have -53 plus -135. It's -188. And then over here, this is going to be 2 times 9 is 18, so 20 times 9 is 180, and it's negative. Put those together. -188. So our -9 is good. Check number 2. Got to pick something in this. So greater than -9. 0 works. It's greater than -9, so I'm definitely using 0. So that just cancels this out. So I get -53 using the actual sign. Less than or equal to -8 plus 20 times 0. Goes away. It's -8. So is -8 greater than -53? Yes, it is. The answer is good. All right, the rest of these now, I don't have to show checks, so we can fly through this. All right, out of these two, the negative is smaller, so I'm going to get rid of it by adding 5y, which cancels out a -5y, minus 13, get -21, divide by 7, and y is less than -3. So again, I never have to worry about flipping as long as I get rid of the smaller of the two, create a positive coefficient. You never have a negative that you have to divide by and flip. -4n and 6. -4n is smaller. I'm getting rid of it by adding 4n. Minus 29. So -15. Divide by 10. 1.5 is perfectly acceptable. You'll see it is a fraction in the book. They just simplified this to 3/2 by dividing by 5. So either one is fine. No flip. I'm going to do -1.5. That's the same thing as -3/2. Close towards the end, just like the answer is on the key. Number 8. 3 times a number, that's 3x, is less than 2 times the same number. Find such a number. Okay, so I was sitting here thinking for a second because I was trying to solve this. If we're going to have an x on both sides here, you're going to go ahead and you're going to minus the smaller one, so minus the 2x. So I'm going to get an x on this side less than, and then over here I've got nothing left, right? So you got to put a 0. So the answer is x is less than 0. Now they're just asking you to find such a number. So they're asking you to just find a number that can be plugged into this. So any number that's less than 0 is good. So an answer like -1, -5, any negative number will make that true. And think about why that is. 3 times a number is less than 2 times a number. For any positive, you take 3 times that number and 2 times that number. 3 times the number is going to be bigger. So the only way this is going to be true is if it's a negative. And 0 doesn't work either because they're going to be equal to each other, not less than. So the only way that 3 times the number is less than 2 times the number is if it's negative. So writing this out, 3 times the number is 3x. Is less than 2 times the number, that's 2x. Now, sometimes they say 3 more than 2 times the number, where you'd have to do plus 3 or something like that, which creates more of an inequality to solve. This one was a little goofy because this clears out and leaves you 0, but that is the actual answer. X is less than 0, which tells you it's any negative number. Okay, number 9. First thing you should do here is simplify, and this is a negative 4 when you multiply. So I get a negative 4x and I get a negative 8. I should fully simplify this side. That's a 9 and a minus 8. That's a 1. So I have negative 4x and a positive 1. 9 minus 8 is positive 1, so plus 1. Now that my side is fully simplified, I'm going to get rid of the smaller x on whichever side it is. That'd be negative 4x. I'm going to add 4x. So 1 less than 14x, divide by 14. And we're just going to leave it like that. So x is greater than 1 over 14. All right, simplify this side first. So put these together. Don't try and subtract from the same side or add on the same side. You can't do that. You can only do that once on the left of the inequality and once on the right. So over here, since they're on the same side, put them together. It's a 7 and a minus 1. That's a 6y. Now, this was a special case where technically this right here is the smaller of the two, negative 5. But if I go ahead and get rid of it, that's going to go ahead and clear out this side. So I might not want to do that. It's going to create a 0, and then I would have to move the 8 and then fill that side back in. Now, the advantage of doing that is as long as you know that you're going to put a 0, you still maintain a positive. Whereas if you decide all of a sudden, you know what, I'm going to go ahead and get rid of the 6y so that I don't clear out this whole side, well, that's fine. Still going to get it right. Negative 11x. But when I divide by negative 11 here, this has to flip. So my answer is negative 8 over 11. X is less than or equal to. So if I had done it the other way, let's show that real quick. Let's say we wanted to still add the 5y. So this right here would be 0. It's gone. We get 11y plus 8. So I would have to minus 8 from both sides. So I get negative 8. 11y, divide by 11. And I'm still going to get y is less than or equal to, or x, whatever the variable is, negative 8 over 11. So I get the same answer. So as long as you know to put 0 there, it may be to your advantage to do that because we still create a positive coefficient to our variable. And so when we get to that last step of dividing, we don't have to do any flipping and we get the right answer. So that's going to be a personal preference, what you want to do. If you're okay with clearing out a side and putting a 0, then stick to your rule of getting rid of the smaller of the two, and you'll create positives. But if you realize, you know what, I don't want to clear that out, it makes an extra step, I'm going to go ahead and clear this one out, create a negative coefficient, then just don't forget to flip. All right, number 11, in solving the inequality given here, you must decide which term to eliminate first, the 12x or the 20x. Explain why this decision matters more for solving an inequality than an equation. So we're going to put it in words. Getting rid of the smaller coefficient, big word, creates positive coefficients. This is important in an inequality because negative coefficients create situations where you have to flip the inequality when you divide by the negative. And you don't have to do that in an equation. All right, that's through number 11. We got 18 to 20. 18 to 20 are in the review section, so going back to some earlier work from the chapter. Okay, number 18. In 2015, we had a population of 840 and increasing by 12,000 per year. Montana has this many, increasing by this many. If these rates continue, how many years after 2005 will they be equal? So we're going to write these as expressions and set them equal to each other. So we have 840,000 plus 12,000 per year. I'm going to call that X. You can use Y. When does that equal Montana, which is 935 plus 6,700 per year? So it's just big numbers, same thing. So as I look at this, I'm going to want to get rid of the smaller of the two, which is the 6,700. So I still have 935 on this side. So 12,000 minus 6,700 is 5,300x. So now my x is isolated. I'm going to minus this, so I can start getting that x by itself. So 935 minus 840 is 95,000. And now we're going to divide by the 5,300 to get it away from that x. And this is the answer that I get, 17.9. Remember what x represents. X represents years. So it's just about 18 years. So your final answer is, they'll have the same population in about 18 years. 19, on a coordinate grid, graph these two. Coordinate grid is your 4-quadrant graph. X equals -5. You go to the x-axis. -5 is the line that's always on that. This is x equals -5. And y equals 9 up here. Hits the y-axis at 9. No matter where you go, the x value changes. The y value is still 9. Okay, that's part A. Part B, give the coordinates of the point they have in common. So the point they have in common is where they hit right here. So at that point, we know the x value is -5 because we haven't gone to the left or the right. The y value stays, the x value stays -5 everywhere on this. So the point that they hit is -5 for the x value, and the y value up here is 9. Because no matter where I go on this line, the y value is 9. So the x values change. The only place it's going to hit is when it has the same x value as this line, which is always at -5. So my answer is -5, 9. And 20. Okay, sweater on sale costs 35 and a pair of jeans on sale costs 27. Altogether, that's $62. They originally cost a total of 86. Okay, so right now they're costing 62. 86 minus 62. That's $24. So they're $24 off total. What's the percent of the discount? Rounded to the nearest percent. So this is the discount, not the percent. This is the discount. So $24 off of, let's say, a $30,000 car. That's not much of a discount, very small percentage. But $24 off of $86, that's a pretty good discount. And so we have to figure out the percentage. We're comparing it to what it started as, not what it became, what it started as. $24 came off of what? What percent did it represent that it came off of? So we're comparing it to the 86. So $24 is what percent of 86? Divide by 86. So 24 divided by 86. I get this, and it says round to the nearest percent. So that's the nearest whole number. So first of all, this moves 2 spots to the right. It's 27.9. So when you round that to the nearest percent, 27.9 is 28%.